Section 6.4 deals with the idea of inverse trig now. Notice that inverse trig has these little negative ones. Be careful, they do not mean take the reciprocal. It means inverse trig. It's a poor notation. For example, if I had 5 to the negative 1, that actually means take the reciprocal. It does not mean that on here. They used a poor notation. So inverse trig is to find the angle. So we've been given the angle and found the side lengths, or the ratio of the side lengths. Now I'm going to give you the ratio of the side lengths, and you're going to tell me the angle. So a little bit about what we're doing here. If I were to say the sine of something is 1/2, for example, and I asked you, what is that angle? That would give me that. That's inverse trig, basically. So this is equivalent to me saying, what is the inverse sine of 1/2? It's that same question mark. What is that angle? Now, here's the issue. If I think unit circle stuff, the sine is 1/2 when I have a 30-degree in the first quadrant, because the opposite side length here is 1/2. But the sine is also positive 1/2 when I have a 30-degree angle in the second quadrant. Sine is positive in both those quadrants. So really, there are two angles that make this true. There's 1π/6, that first one, and this one, which is 5π/6. That's a problem. If I want to call this a function, remember all the way back to when you first learned about functions, functions can only give you one answer. They can only spit out one answer. Right now, this looks like I could spit out two answers. And actually, it turns out I could spit out infinitely many answers, because I could spin all the way around and land there. I could spin all the way around a few times and land there. There's an issue here. So if we didn't fix this, then we'd break calculators. When I try to do inverse sine of 1/2, my calculator wouldn't know to give me π/6 or 5π/6 or maybe 13/6 or something. So mathematicians basically had to say, all right, let's fudge the numbers. And here's what I really want you to focus on is the range here of these. Mathematicians said, if we do inverse sine, we're only going to look at answers between these angles, -π/2 and π/2. So -π/2 would be rotating back π/2. Positive π/2 would be rotating the normal way, π/2. Basically, it's saying if we're doing inverse sine, only look over there on the right side. Don't even look on the left side. And you'll notice that it's really basically the same thing for inverse tangent. So if we're doing an inverse sine or an inverse tangent problem, we're automatically going to cross out the left side of the unit circle stuff, and our answer's got to lie on the right side. For inverse cosine, they had to go with a different one. Well, and here's why we did the inverse sine this way. Sine and tangent are both positive in the first quadrant. Sine and tangent are both negative in the fourth quadrant, with the all students take calculus thing. So that covers my positive and negative possibilities. That doesn't work for cosine though, because cosine's positive in both those. So they had to go with a different rule for inverse cosine. They said, okay, let's only look between 0 and pi. So if we're doing an inverse cosine problem, there's 0, there's pi. We're only going to look at the top half. We're not going to look at the bottom. Because cosine is positive in the first quadrant and negative in the second. So what this boils down to, if we're doing inverse sine or inverse tangent, we're going to cross out the left side before we even get started. If we're doing an inverse cosine, we're going to cross out the bottom before we even get started. So for number 1, inverse cosine, all right, immediately cross out the bottom. My answer is not allowed to lie down there. Okay, now I say, all right, it's inverse cosine of a negative. I know I'm going to be in the second quadrant then. Now I have to ask myself, what angle has a cosine or adjacent of a half? This is from last section. That would be a 60-degree reference. The adjacent here is the 1/2, the short leg. Remember, it's asking me, hey, what is the angle to that spinner? Well, this relies on me knowing those radian angles pretty well. That's 1/6, 2/6, 3/6, 4 pi over 6. So 4 pi over 6, which reduces to 2 pi over 3. Inverse trig usually at the beginning really throws students off, but if you think about it as normal trig, it might help. Think of it if I asked, hey, what is the cosine of 2 pi over 3? Hopefully you'd be able to build the triangle in the right place and you'd find that it's -1/2. We're just basically doing that in reverse. For letter B, inverse sine. Inverse sine, I immediately cross out the left side. Again, this is only when you're doing inverse trig. It's negative, so that means I'm going to be down in the fourth quadrant somewhere. And now I ask myself, what angle would have √3/2 for the sine? So what angle has an opposite of √3/2? Well, that's a 60-degree again, because that opposite leg is √3/2. Now here's where you got to be careful. I am not going to rotate this way to get to that angle. I'm not going to do that because it said my angle has to be between -pi/2 and pi/2. So that means instead I'm going to rotate the opposite direction, 1/6, 2/6. So that angle is -2/6 or -1 pi/3. Letter C, inverse cosine. Before I even look at the number, inverse cosine is cross out the bottom. This time the number's positive, so I'm going to be in the first quadrant. √2/2, that should be the, woohoo, this is the easy one. √2/2's only happen with 45s. So my angle's 45 because the adjacent on a 45, I'm doing cosine, the adjacent is √2/2. So the question is, what is that angle? Well, that's just 1 pi/4. And again, think of them in reverse if it helps. If I asked you for the cosine of pi/4, hopefully you would calculate that that is √2/2. I'm just doing it in reverse. Inverse tangent. Inverse tangent, just like inverse sine, is cross out the left. It's negative, so I'm definitely in the fourth quadrant. This tangent's negative down there. Now, tangent usually is a little trickier because you got to think opposite over adjacent, but as you do more of these, you'll get faster with them. It is the 30-degree reference where the tangent would be √3/3. I can test that by actually running the tangent. Tangent is opposite over adjacent. So opposite over adjacent, I'd multiply by the reciprocal. That would leave me with 1/√3. If I rationalize that, I do get root 3 over 3. So what was all that for? That was to know that it's a 30-degree reference where the tangent is root 3 over 3. And again, there's only so many ways I can put these together, so you'll get used to the numbers. Okay, so again, what am I asking for? I'm asking for what is that angle? Well, that is back 1/6. So negative pi over 6. Inverse sine, before I even look at the number, cross out the left side. Now this one's a little trickier, 0. That should tip me off that I'm probably on an axis. So where is the sine 0 over here? Well, the sine is actually 0 when the spinner's hasn't moved at all. Remember, this y coordinate is the sine. And again, what is that angle? Well, I didn't spin at all. That angle is also 0. Now be careful, that inverse sine of 0 is 0 radians. If it helps, maybe write rad next to it. So you know that's a rotation of nothing. The letter F, inverse tangent. Immediately cross out the left. Now careful, tangent is 1. That doesn't happen on an axis. Tangent is opposite over adjacent. Tangent is 1 with a 45. And since it's positive, it's in the first quadrant. Because remember, if the two side lengths are the same length, opposite over adjacent would equal 1. So that angle is pi over 4. And again, think of these in reverse if it helps. If I said, hey, what's the tangent of pi over 4? Hopefully you'd say, oh, it's root 2 over 2 over root 2 over 2, which is 1. Letter G, inverse sine of negative 1. All right, inverse sine, cross out the left. Where is negative 1 for sine? That's only going to happen when the spinner faces straight down. Because again, the sine is the y coordinate. And again, it's asking me, all right, how much did that spinner rotate to get to there? It rotated back pi over 2 radians, negative pi over 2. For letter H, inverse cosine is cross out the bottom. Very similar to the previous one. Where is the cosine negative 1? Well, that happens when the spinner lands over here, because that has the coordinates negative 1, 0. Remember, the cosine is the x. So again, the question is, hey, what did that spinner rotate to get to there? It rotated pi radians. And for the last of this set, inverse tangent of root 3. Inverse tangent, cross out these guys. It's positive, so I'm in the first quadrant. Root 3, well, that should tip me off because up here, root 3 over 3 was a 30-degree reference. So I'm betting root 3 by itself is a 60-degree reference. Think about what the opposite over adjacent would be. It would be root 3 over 2 over a half. If you multiply by the reciprocal, you get root 3. It's asking me, hey, what's that angle? Well, that's 1/6, 2/6. So 2 over 6 or pi over 3. For number 2, this we'd be using a calculator, so you'll have some in your homework like this, because there's some inverse trig where we just need a calculator. Make sure you know how to set your calculator to radians, because you'll need that on your homework. It won't matter for quizzes and exams. But either your calculator or an online calculator, make sure it's in radians. All you're going to do is inverse sine of 3/5. And if you put this in your calculator, you should get about 0.64 .350 if you round to 5 decimals. Just make sure you know how to do that in your calculator. For number 3, we can do this one without a calculator. Find all angles between 0 and 180 that satisfy this equation. So this is basically how I introduce this. Hey, what's the angle where cosine is negative √3/2? And it's saying only between 0 and 180. So that's still cross out the bottom. Well, I know cosine's positive in the first quadrant, so it can't be over there. So it's got to be over here. We already did this problem, or similar ones. When the cosine is √3/2, that's a 30-degree reference, because the adjacent length is the √3/2. So what is that angle? And now this time it's wanting it in degrees. So that angle is 150 degrees. Again, notice I need a calculator for that one. On number 4, now I will need a calculator. Find all angles between 0 and 180. So reset your calculator to degrees this time. .3 is not one of my normal ratios, so on this one, I'm going to have to, in my calculator, and again, we're back in degrees, do the inverse sine of .3. If you do that, rounding to 1 decimal, you should get 17.5 degrees. Now, here's the hitch. It said to find all angles where this happens. Well, I just found that 17.5 degrees works. But here's the thing. Sine is also positive in the second quadrant. Now you might be saying, well, wait a sec, didn't we just say we have to cross out the left side when we do inverse sine? There's a difference between finding a functional value, which is what we did here, versus solving an equation. Equations can have multiple answers. It's kind of like saying, what's the square root of 4? It's 2. But what about x squared equals 4? Well, that's plus or minus 2. Same kind of idea here. It's an equation, so we have multiple possibilities. So there's also this angle where the sine would be 0.3 because it's positive. That reference would be the same 17.5. So if I do 180 minus 17.5, that angle is 162.5. That's definitely tricky, but I'm getting you introduced to that because we're going to be solving some equations later on that involve trig, and we've got to be aware of that. We could have more than one answer sometimes. All right, that'll do it for the first video on this section.